Hello everyone. Today we are going to look at trigonometric ratios for any angle that is between 0 and 360. Until now, you work with the trigonometric ratios of acute angles and you use right angle triangles. Today we are going to use a very different approach. We are going to use Cartesian plane to draw our angles. So as you see, we have a Cartesian plane here, x-axis and y-axis. Let's start with remembering how to number the quadrants. So this is quadrant number 1, quadrant 2, quadrant 3, and quadrant 4. When we are sketching angles in Cartesian plane, we always put the initial arm on positive x-axis. And if we want to draw positive angles, we go counterclockwise. And if we need to draw a negative angle, we go clockwise. So let's look at some positive and negative angles. So when we are sketching angles, again, the initial arm always must be located on positive x-axis. If we need to draw, let's say 0 degree, so the terminal arm, you don't rotate it at all, so that's going to be on top of this initial arm. So this is 0 degree. So if the terminal arm going in a positive direction, if it is located on positive y-axis, then we have 90 degree, positive 90 degree. If while again the initial arm is on positive x-axis, if terminal arm is located on negative x-axis, then we have positive 180 degree. If the terminal arm is located on negative y-axis, then we have positive 270 degree. And finally, if we need to draw 360 degree, so we go all the way back to positive x-axis. So again, the terminal arm is located on top of the initial arm on positive x-axis, so that gives us 360 degree. Knowing this will help you a lot when sketching the angles. Let's say you need to sketch 200 degree. So 200 degree is between 180 and 270. So you know that the terminal arm of 200 degree must be located in quadrant 3. So this gives us 200 degree. Or let's say you want to sketch 300 degree. So you know that 300 is located between 270 and 360. So that terminal arm should be located in quadrant 4. So we can draw 300 degree in quadrant 4. Let's look at some negative angles. So again, we put our initial arm on positive x-axis. So 0 degree is here again, for the terminal arm is on also positive x-axis. So going in negative direction or clockwise direction, if terminal arm is located on negative y-axis, then we have negative 90 degree. So if the terminal arm is located on negative x-axis, then we have negative 180. If terminal arm is located on positive y-axis, going clockwise direction, we have negative 270 degree. And finally, if we go all the way back to positive x-axis, that gives us negative 360 degree. Okay. So again, this is going to be very helpful when sketching negative angles. Let's say you need to sketch negative 150. So you know that negative 150 is between negative 90 and negative 180. So you can just draw the angle, and you know that it must be located in quadrant 3. So that is negative 150 degree. And that is summarized here in this diagram. So we see 0 degree, 90, 180, 270, and 360. Similarly, going in negative direction, 0, negative 90, negative 180, negative 270, and negative 360. Let's say, suppose we have a point on the terminal arm. Okay, so this is the terminal arm of an angle theta, and we have a point on the terminal arm. Let's say coordinates of that point is x and y. If I drop a perpendicular line to x-axis here, I can create a right angle triangle. Okay, then what can we say about the measurements of the sides? So if the x coordinate of the point is x, so this distance here is going to be x. So y coordinate of the point is y. So therefore, this side of the triangle is y. So hypotenuse is called r. Why is that? Because let's say initial arm is on positive x-axis and you are rotating the other arm, okay? And as you rotate it, actually that arm creates a circle in the Cartesian plane, okay? And the radius of the circle is same as the length of this hypotenuse. Therefore, usually you will see it as r here. Now, the question is, we are finding three primary trigonometric ratios. So we are going to write sine theta, cos theta, and tangent theta. Now, let's look at the triangle that we created here. So if this is theta, sine theta is opposite over hypotenuse. Opposite is y, hypotenuse is r. So we can say that is y over r. So y coordinate of the point over r. Let's look at cos theta. Cos theta is adjacent over hypotenuse. So adjacent is x, hypotenuse is r. So that gives us x over r. So x coordinate of the point over r. And tangent, again looking at this right angle triangle, opposite over adjacent. And that gives us y over x. Y coordinate of the point over x coordinate of the point. Let's look at an example here. So we have a point 6 and 8 lies on the terminal arm of an angle theta in standard position. Determine 6 trigonometric ratios. So let's draw our x and y axis first. Approximately, let's put the location of this point. So x coordinate is 6 and y coordinate is 8. So that is the point. And the terminal arm of the angle is passing through that point P. Okay, and the angle theta is right here. So we have again a right angle triangle here. So let's write the ratios. Sine theta, you can use this triangle or you can just use the previous findings to write the ratios. Okay, so what did we say from the previous question here? We said that sine theta is y coordinate over r. So y coordinate here is 8, but we didn't find the r yet. So let's find it. So using this right angle triangle, we can find r using Pythagoras. So r square equals 6 square plus 8 square. So that gives us 36 plus 64. Okay, and that is 100. Then r is square root of 100. Again, it cannot be a negative number. We only take the positive square root here. So that gives us 10. So we just got r being 10. So 8 over r is 10. So if we simplify this fraction, we get 4 over 5. So now let's look at cosine theta. we said cosine theta is x over r. X coordinate is 6 and r is 10. Again, if we simplify the fraction, we get 3 over 5. So let's look at tangent theta. Tangent theta, we said, is y over x, y coordinate over x coordinate, 8 over 6. Simplify the fraction, we get 4 over 3. This question is asking all 6 trigonometric ratios. Therefore, we also need to get cosecant theta, secant theta, and cotangent theta. So we know that cosecant theta is 1 over sine theta, or if we use these letters here, so sine theta is y over r, so cosecant theta is r over y. Okay, or we already have the sine theta here, we can flip the fraction, we can do 1 over 4 over 5, and that will give us 5 over 4. And secant theta is 1 over cos theta. If cos theta is x over r, cosecant theta is r over x. So we can use this cos theta ratio here. 1 over 3 over 5 gives us 5 over 3. Cotangent theta is 1 over tangent theta. Okay, if tangent theta is y over x, cotangent theta is x over y. So similarly, we can use this tangent as well. Okay, and that will give us 3 over 4. Now let's look at the signs of trigonometric ratios in different quadrants. Let's start with quadrant 1. Let's say theta is between 0 and 90 degrees, and when you sketch it, you know that it's going to be in the quadrant 1. So coordinate of the point that is on the terminal arm is x and y, and we know that in the first quadrant, x coordinate and y coordinate are both positive. And this is your r. Okay, and we said that sine theta is y coordinate over r, y over r. R is again the radius of the circle that is created by the rotating arm. So radius is always positive. So r is always positive here. So then y coordinate is going to determine the sign of sine theta here. So we already know that y is positive. So then the sine ratio is going to be positive in the first quadrant. So let's look at cosine theta. We said that it is x over r. X coordinate is positive here, r also positive. Positive over positive gives you positive. Tangent theta is y over x. So y coordinate is positive, x coordinate is also positive. Therefore, the tangent theta is also positive in the first quadrant. So when we look at it, all the ratios, trigonometric ratios, are positive in the first quadrant. So I'm going to say all is positive. So let's look at quadrant 2. In quadrant 2, we know that x coordinates are negative and y coordinates are positive. And the angles between 90 and 180, so this is, as you remember, positive 90 degree, and this is 180 degree. So if you have an angle between 90 and 180, you know that it's going to be located, the terminal arm is going to be located in the second quadrant. So sine theta is y coordinate over r. So y over r. So y is positive in the second quadrant. R is always positive. So we end up with a positive value here. So let's look at cosine theta. X coordinate over r. Negative x over r. So negative value divided by positive value. So that will give us negative for cosine ratio. Tangent is y coordinate over x coordinate. Y over negative x. So positive value divided by a negative value. So that will give us negative. As you see, in the second quadrant, only the sine ratio is positive and the others are negative. So I'm just going to put S here. So only sine is positive. Let's look at an angle that is in quadrant 3. So if you have an angle theta between 180 and 270, so this is 180, this is positive 270. So if you have an angle theta between that, you know that the terminal arm is going to be located in quadrant 3. So again, using these findings, so we're going to take y coordinate and divide it by r. So y coordinate is negative. We're going to divide it by r. So negative number divided by positive, we end up with a negative value. So cosine theta is x coordinate. So in the third quadrant, x coordinate is negative. We're going to divide this by r. So again, we end up with a negative value. So tangent theta is y coordinate over x coordinate, negative y over negative x. So negative signs cancel each other, so we end up with y over x. So it looks like tangent is positive in the third quadrant. So only tangent is positive. So I'm just going to put T to represent that only tangent is positive in the third quadrant. Okay, how about if we have an angle theta between 270 and 360? So 270 is here, 360 is here. So if you have an angle that is between 270 and 360, you know that the terminal arm is going to be located in quadrant 4. In quadrant 4, x coordinates are positive and y coordinates are negative. Okay, so sine theta is y coordinate over r, so negative y over r. That will give us a negative value. So cos theta is x coordinate over r. X is positive here, x over r. So looks like this will give us a positive value. So tangent theta, y coordinate over the x coordinate, negative y over x, and that will be a negative value. So looks like in quadrant 4, only cosine ratio is positive and the others are negative. So I'm going to put C here. So this is giving us the cast rule. It is called cast rule. So when we are reading it, we don't start from quadrant 1, but we start reading it from quadrant 4. So we go from quadrant 4 to 1 to 2, 2 to 3, and we have cast. Okay, so this is very helpful when finding the signs of trigonometric ratios of the angle in a given quadrant. So now let's look at the related angles. The related angles. So let's say we have a sine 30 degree, we have sine 150 degree, sine 210 degree, and sine 330 degree. So 30 degree, as you know, is a special angle. You learned it with the last lesson. So the sine ratio of 30 degree is 1 over 2. So you wouldn't know the others, but I'm just going to give you that this is 1 over 2. You can check it with your calculator. This is negative 1 over 2, and this is negative 1 over 2. As you see, those four angles, the sine of those four angles, have the same numerical value. However, two of them are positive and two of them are negative. So why is that? So what is the relationship between these angles? Okay, so let's sketch these angles and see why they are related. So initial arm is on positive x-axis. So 30 degree is an acute angle, positive one. So terminal arm is here. So that is 30 degree. So let's sketch 150 degree. So x, y, and we said that this is 90 degree, this is 180 degree. So 150 should be located in the second quadrant. So positive 150 degree, and that is the terminal arm. So let's sketch 210 degree. So this is 180, this is 270. So 210 degree should be located in quadrant 3. so 210 degree. So let's look at also 330 degree. So this is 270. This is 0, also 360. Okay, so 330 should be located, the terminal arm of 330 should be located in quadrant 4. So this is positive 330 degree. Okay, so let's look at the angle between the terminal arm of these angles and closest x-axis. Okay, so this is the terminal arm, closest x-axis is here. Oh, so this is 30 degree. It is same as the angle theta. So let's look at 150 degree. Terminal arm is here, closest x-axis is here. So the angle between the terminal arm and closest x-axis, okay, so this is 180, that is 150. So we need to subtract 150 from 180 to get this angle. So that gives us 30 degree as well. So let's look at 210 degree. So terminal arm, closest x-axis, so that is 210 and this is 180. So 210 minus 180 gives us 30 degree here. And finally, let's look at 330 degree. So this whole, so this is the terminal arm, this is the closest x-axis, so that is the angle we are looking for here. So to calculate that, so the whole turn, one full rotation would be 360, but the angle theta is 330, so this angle here must be 30 degree. So when you look at all those diagrams, you see that the angle between the terminal arm and the closest axis is the same for all of those angles. So that angle is called related acute angle. And we usually represent it with a symbol beta. Okay, so the angles that have the same related acute angle are considered related angles, and their sine ratio, cosine ratio, and tangent ratio will have the same numerical value. However, two of them will be positive and two of them will be negative. So related acute angle beta is the acute angle between the terminal arm of an angle in standard position and the x-axis. Okay, this is just a summary. So if we have an angle in quadrant 1, this is angle theta, and beta, which is related acute angle, is same as angle theta. Okay, in the second quadrant, so this is angle theta, principal angle. So this is angle beta. So what is the relation? Let's say to get beta, so you need to subtract theta from 180. In the third quadrant, so this is angle theta, and this is angle beta. So to get beta, we need to take theta and subtract 180 from theta to get beta. And in the quadrant 4, this is angle theta, and this is beta. To get beta, we need to take 360 and subtract the theta from 360 to get the beta. Okay, and similarly, you can apply this. Let's say you know beta. How would you calculate the theta? Okay, so in the first quadrant, theta equals beta. In the second quadrant, theta equals 180 minus beta. In the third quadrant, theta equals 180 plus beta. And in quadrant 4, so 360 minus beta gives you the theta. So now we are going to do some examples related to this topic. Please continue with video